not just the thoughts, but the actions. With that call to action, let me hand it back to Dr. Ashok, and I wish the event much success.
Thank you, sir, for your wonderful address. And let me share the context, for the discussions as you have rightly put in, sir. With your permission,
yes.
As you rightly pointed out, sir, that the context for the discussions we have already, laid down here. I have jotted down a few points where at micro level, that means at the building design level, when we talk about COVID pandemic safety features, we need to have, design for enhancing the natural ventilation, design to enhance the daylight and sunlight, flexible design approach with sustainable features. And all these will definitely have considerations of passive design and building physics principles, wherein the first attempt should not only be, towards the passive design, but to reduce the thermal load, as well as that will also lead to energy bill reduction. And similarly, design for social distancing, design of HVAC systems, design and development of air purification and disinfectant systems, design for improved indoor air quality, surface finished materials and construction methods, and many more. And I'm sure our panelists, our special invitees are going to throw some light on these micro level issues. Similarly, at the macro level, where we are talking about large villages or urban villages, towns and cities, where planning and integrated development becomes a very, very important issue, and wherein climatic vulnerability and extreme weather events, extensive urbanization, haphazard development are core issues, and we need to have planning for reduced UHI, urban heat island and heat stresses, and technologies for reducing energy consumption, CO2 emission, and reducing the urban heat island, and many more. And we already had several, extreme events or weather events in the recent parts. March 2022 was the hottest in almost more than 100 years, Delhi. And you will find that in villages also several cloud bursts and several extreme events are happening. Only just a couple of days I was in my village in Rangad, Himachal Pradesh, where I also experienced a severe, hailstorm and wind, just like a cloud burst with a wind speed of more than 400 kilometers per hour. Many this electrical pole lines were uprooted. Many trees were half cut and half were uprooted. Many the electricity was disturbed for almost 60 hours, and with the help of one of our colleagues, my sons, friends, IAS officers from Delhi and other areas, they helped in restoring these normal life. So same, you can see the extreme weather events that have happened in the part of Uttarakhand, and let us listen to our plenary speakers. Now I invite Dr. Shrikant K. Panigrahi for his talk on climate change and its impact on urban ecosystems. Ladies and gentlemen, yes, now I invite Dr. S.K. Panigrahi. Over to you, sir.
Thank you very much, Dr. Ashok Kumar, for the invitation and giving the opportunity to share my views and opinions and experience on the very important topic. The topic for the conference is climate change and its impact on urban ecosystem. So I will little modify it to climate-induced urban vulnerability and building resilience in the context of of a city, New Delhi case study. So basically, all of you are quite aware about the issues. Uh, mm, the problem of climate change, the challenge is enormous. And now we are going through a crossroad where the ocean currents have changed their path. Ocean cold currents has become hot currents. Many of the air pressure belts has shifted, which has resulted in change in monsoon pattern, more of rainy days, uh, and more rain in few number of rainy days, and there is a lot of change in nature. All these changes are happening because our ecosystems, which supplement to each other, is getting eroded, getting damaged. The kind of the uh, we all are created by nature. We all will be go get to nature. But we humans many times forget our identity, and we act very smart. And nature has a limit of tolerance. And now we are in a difficult stage. The one by the end of the century, the kind of the temperature that likely to be, there are different scenarios, 1.5 degree, 2 degree, 3.5 degree, 4 degree. And if you consider business as usual case, the way the temperature is, if you think there is no increase, if the present trend is continues, uh, we have many difficult times to come. And much before the end of the century, by 2075 to 80, um, the situation will be very, very alarming. And IPCC AR6 has been released in last August 9th. And we are reading so many reports, and we are quite familiar about the kind of the pace and rate global warming is taking place, and how the challenges are ahead. Particularly if you consider, we have huge impact of climate change into the humanity. It is in terms of lot of natural disasters like cyclones, floods, loss of life and property, and in many type of disaster risks that we are encountering throughout the globe. We have huge reduction in water quality as well as quantity. The agricultural productions has gone down. The sea level rise is constantly increasing. The biodiversity loss are enormous. Now we are at 1.2 degree higher, where the maximum limit is 1.5. So when there is a 1 degree centigrade more, the impact is to the loss of the biodiversity in terms of flora and fauna, the kind of the natural life we have extincted, that is to the tune of 30 to 35%. There are many sensitive species which cannot tolerate such high temperature has vanished away. And there are rise in vector-borne diseases, and wetlands are vanishing, and there are huge catastrophic consequences of the climate change in many ways. And urban ecosystem, it has not uh, kept itself without any impact, and it is going through equally a very difficult climate change challenges. Um, the If you see in India's context, we are a tropical country. We receive maximum sun. We are among the highest receiving sun rays, and we are a part of the tropics. So, as such, in natural way, we have abundance of sun. And when the global warming is again add additional dimension, our situations are more alarming. There are many international reports like climate change risk index, and so many where India's positions in Southeast Asia in particular has been assessed, and vulnerability index has been calculated. So, urban, then I will discuss about the built environment and the impact of this on urban context. In our rural hinterlands, the we have the kind of the concrete coverage are less. The population are scatteredly distributed. They are not as dense as urban areas. So the kind of the impact of adversity of climate change is comparatively less. But in urban areas, where there is a large number of people are accommodated with a limited land mass, where the population intensity per square kilometer is very high, the impact is very, very high. In ecological terms, cities are parasites. Urban areas consume huge resources. The urban dwellers, they need a lot of milk, not a lot of water, lot of fresh air. They need a lot of green vegetables. They need everything in huge quantity, and they need huge quantity of energy. They and what are the output? What they return back? They return back huge solid waste, huge liquid waste, huge landfills, huge uh, um, gaseous waste, that is air pollution. And Delhi NCR is the number one polluted city in the globe. And its ranks uh, are not reducing. There are, we at IIST along with IIT Kanpur did some study for the government of Delhi long ago, about 7 to 8 years ago. And the things are very clear what needs to be done, and solutions are available, but things are not happening. And so the urban areas are comparatively more vulnerable, with adverse impact of climate change. So we need special attention for urban areas. Uh, so there are different mathematical models. A lot of studies has been done. We have partnered with Center for Atmospheric Sciences with IIT Delhi, and different modeling studies on impact of urban heat islands. It is in recent times, as Dr. Osok Kumar very well said, the number of deaths because of heat waves are highest in India in the globe, and particularly in this March, it has gone to peak. And the uh, how the heat islands forms, what is the phenomena, it is all well known. So I'm not expanding that. And the implications are many. Like our cities are encountering with urban flooding, urban loss of biodiversity, urban air pollution, urban heat island formation, and the pollutants, and heat is not able to dissipate and disperse, and it is getting tapped in a limited uh, areas. So researches are there in its place, policies are there in its place. We need a synergy, and we need to work together, uh, coming out of these silos. So one of this initiative on the eve of 75 year celebration, Azad Ka Amrit Mahotsav, this connecting research with industry, we need such initiatives in bringing all the stakeholders together under one platform, and should have collective efforts one after another. The cloud burst has increased, lightning incidents and causes due to lightning has increased. Earlier, it was confined to few eastern states like Bihar, Jharkhand, Odisha, and now it is spreaded throughout the country, and Himachal, Ladakh, and many Himalayan states are not free from it. Mm, so we need to have a robust action plan, and we need to. Uh, Many people argue we need to reduce our global warming. The scientists are working, policy framework is there. UNFCCC has its own framework. Paris Agreement, India is committed. We have declared advanced Paris agreements in COP26 at Glasgow, which Prime Minister has put forward as Panchamrut. Um, and India is trying to achieve 500 gigawatt of non-fossil, renewable-based non-fossil energy by 2030, and reduce the carbon intensity at the tune of um, 45% of the India's intensity, and increase of carbon sequestration portfolio. India is whatever committed right from the beginning in the Paris 2.5 to 3 billion metric ton reduction of carbon dioxide equivalent, and carbon net zero by 2070. But we have our scientist community and as government is truly working to become net zero by 2047, when India will be celebrating 100 years of its independence. And that is feasible, but that is very tough. And doing all these efforts, we will be achieving 50% of our energy basket into renewable and non-fossil fuel route by 2030. So we need to go a long way with sustained efforts. So the very important is till we keep on reducing the our greenhouse gas emission from the atmosphere to retrieve the earth. It will take a longer time. The so much greenhouse gases is not emitted in a day or a limited time. All the industrial revolution and the kind of the emissions that is thrown to the carbon space of India, the planetary sky, is over hundreds of years. So it will take a huge time also to become, the planet is to become net zero. So, and to retrieve the planet. So in between, we need adaptation to accelerate in our built environment, particularly to reduce the urban vulnerability, and to make life little more comfortable, to reduce the climate refugees, to reduce all the adversity. We should have right policy framework. That is what the that is happening, and um, but at the same time, we surveyed East Delhi out of uh, other districts of Union Territory of Delhi is most vulnerable to climate change, and so it needs comparatively more urban resilience. We did a all stakeholders level interview and interaction and primary survey, and we worked out a surveillance strategy, urban resilience, to build the resilience. So it is the things are well known. There is enough research has been done, and now it is high time all the stakeholders to come together in a common platform, joining hand on the eve of 75-year celebration to approach our challenges collectively, to enhance our sufficient urban resilience, to tackle the urban vulnerability that we are encountering largely at different part of the nation. I will keep my intervention here. I would profusely thank to the organizers and my other speaker colleagues, which who are of great eminence, especially Dr. S. Anantha Ramakrishna and Anumita Roy Chaudhary, and there are many other colleagues available in the panel. So they will bring their expertise to make the program successful. Thank you very much. Thank you for the.
Yeah, thank you, sir. Thank you for your wonderful words. Indeed, you have highlighted the importance of the the solutions which are likely to be followed in creating a balance between the built environment and the climate vulnerability in urban areas. And I'm sure with the kind of right policy framework which you mentioned will definitely highlight some of the important issues that this webinar will discuss. Thank you for your remarks on 2047 net zero. No, the target is 2070, but you mentioned that as India celebrates 100 years of independence, so 2047 is the net zero, and with the 50% renewable, I think by 2030, there's a likelihood that we may achieve this target when India completes 100 years of independence. And just to inform you, sir, that we at CBRI also are engaged in several initiatives, and one of the initiatives is to deploy or to design buildings with passive design measures, and also reduce the thermal loads, wherein we have full-scale test beds, wherein we have quantified the reduction in the energy load to the tune of more than 40%, by deploying several passive design measures. So this is how all these interventions are very, very important when we look holistically as a nation for meeting the net zero targets. So thank you very much, and we look forward to have more collaborations. And I'll come back to you after we listen to Dr. S. Anantha Ramakrishna for his talk on air disinfection and purification systems. And I was a part of a team of a CSR strategy group under which some R&D has been carried out, and technologies have been developed. And I would request Professor S. Anantha Ramakrishna to give his talk. Over to you, sir.
Thank you. Thank you very much, outstanding scientist, Dr. Ashok Kumar, for your extraordinary comments, and for the invitation and keeping your views.
Thank you, sir. Thank you. Over to you, sir.
Yeah, sure. I will just start my presentation now.
Yeah. You can share the screen.
Yeah, are you able to see my screen now?
Yes, very much.
So, Dr. Ashok Kumar, when you called me and said that I have to talk about pollution, of course, pollution is a very general concern. But, I did not have too much of expertise to talk on pollution of the kind that people usually talk about. I was wondering what to do. And then, of course, we decided that I would speak on this development of the UVC disinfection systems, which we all carried out jointly. And yes, I mean, pollution means anything that is unwanted in the origin. We want pure air, and presence of infective viruses are also undesirables within the air. So hence a form of pollution. It's a form of biological pollution. So I'll be mainly talking about that and how we went about trying to make things better for the country when the COVID pandemic was upon us. So this work, though I'm presenting it, it is actually a pan-CSIR effort involving multiple institutions. The main players I have written below: CSIO, IMTech, CBRI, IIP. There have been other labs also which have helped us and also participated here. So see, when we started, the COVID pandemic was upon us in March 2020 in India. But by about September 2020, much before WHO even accepted that SARS-CoV-2 is mainly airborne and infects through the air, CSIR laboratories, IMTech and CCMB, had done air sampling measurements, and they had measured the presence of virus in these air. So CSIR was very aware, and it actually kept telling everywhere that the infection is airborne. Our scientists measured the virus in air meters outside a COVID ward or everywhere inside a COVID patient's home and so on. So when we were posed the challenge by the CSIR, now find some solutions to it. We of course could not start off on brand new research trying to see whether some negative ion or positive ion, what is the concentration, etc. We couldn't do that. We wanted a sure short solution, something that has proven that works, because the country was in the midst of a pandemic. People were dying, they needed to be saved. So UV is a proven manner to disinfect viruses and bacteria since about 100 years. And the main problem is it cannot be used in the open where humans are also present, because the UVC radiation is harmful. It causes skin and eye burns and is known to be carcinogenic, causes cancer. So we needed to use it very, very carefully. So we needed to create safe conditions. We needed to validate the solution for its disinfection abilities. The devices needed to be qualified and certified and have certain safety features. But most importantly, it had to be done quickly. So the devices, the solutions that you develop should be inexpensive, should retrofit into existing mechanical ventilation systems. They should be simple so that industry can easily make it. With the present established supply chains, you shouldn't require something so different that nobody has it. For example, at the peak of the COVID pandemic, we were reading that 222 nanometer laser, diode sources can actually be useful because they may not harm the skin directly. They may not harm humans because it's absorbed in a very short thickness of the dead cell region in the skin. But then the problem was nobody had it. So you couldn't use such a solution. So keeping one of the first thing in that context I would like to show you was the air sampling devices that was used by IMTech and so on, which we developed at CSIO here. These simple devices which suck air at a very, very constant rate and which actually push the air through a filter which captures the virus were developed within 3 weeks. And within 3 weeks, IMTech scientists could take them to the hospitals and try to measure. So CSIR could act with great speed whenever required. And we have a lot of these samplers which can be used for many purposes, viral measurement of many particulates and so on. Now this is available commercially. Now, as I said, UV air disinfection is known. It's a non-chemical, no contact method using electromagnetic radiation of short wavelengths. What these do is that the UV photon, when it is absorbed by molecules, the energy attacks the DNA in biological systems. They dimerize the bonds or they even break the bonds. Effectively, they make the virus or bacterium unviable. They cannot reproduce after that. So, the problem in a room is typically like this. I have used Dr. Ashok Kumar's slide here. And, you know, a person who is infected spews out viruses through the respiration. The virus is picked up through the ventilation, pushed through a cooling channel, and pushed back into the same room or maybe into other rooms. So now that becomes a source of circulating the infection around to a person who is not infected. And even if you maintain social distancing, this recirculation of virus droplets containing virus or and so on can actually affect people across rooms and far away from each other also. So this was the main problem that we had to address. And you know, India in summers, it's hot, everybody is using AC and they are all indoors. That becomes one reason why the infection rates become high. And we said, okay, we'll have to use UV light inside these cold ducts and put in a disinfecting intervention there out here where the air comes out, so that it's what comes out into the room is absolutely clean. And to do that, what we did was we faced a challenge actually. There was nobody who could measure what is the dose of ultraviolet which makes the virus unviable at that time. So CSIO developed a chamber along with IMTech in Chandigarh, where we developed a chamber, put it into the BSL-3 chamber there, where we can do tests with such infective pathogens. And what happens is a spray containing live virus, which was developed by IMTech, is sprayed into a chamber. And in that chamber, we have various things like you can put in UV light and so on. So we actually push it through a nebulizer into the chamber, and the chamber, inside the chamber, you sample out the air after treatment or without treatment, before treatment. You can introduce essential oils. You can introduce any modality you want to test it. And after the particular modality, we actually take out these and then measure the, we sample the virus from inside and we measure whether the virus is viable or not, whether it can reproduce or not, whether it is infective or not, in other words. So in IMTech, what happened was we could, using this technique, measure what is the ultraviolet dosage for which we get 99.99% plus, inactivation of the virus. And in CSIO, where we were already making a lot of measurements for UV intensities, we could actually we could actually measure the UV intensities very carefully and make sure what is the dose that is reported here is accurate. And in fact, today, these are the original sources of data in India, and even BIS, takes these sources now. We also have, got all the equipment that we made certified for, zero ozone or things like no UV light leakage. NPL Delhi looked at that problem. The devices have smoke and fire sensors, fire alarms. We got them safety, mechanical stability tests done, electrical safety tests done to get the C certification, and so equivalent of the C certification. And so in other words, we had a fully validated device. Not only that, these devices, were placed in the testbed facility for airflow developed by CBRI in Roorkee, and they were tested on the testbed for several hours for mechanical issues and so on and so forth. And this was done by Dr. Ashok Kumar and his group. So these are photographs of that testbed facility which I'm showing, which was developed, and this is the UV lamp assembly which was done. I will come to the lamp assembly itself in a short while. So these are the lamp assemblies which were developed. These consist of principally mercury vapor lamps with the powers or the sizes and the illumination volumes which are very carefully calibrated, calculated to make sure that the corresponding UV dose for virucidal effects is reached. In each of the ducts, the air column that passes through that comes out completely disinfected to the level of 99.99%. So using, we do a lot of calculations, optical calculations, what is all the intensity, and then we run integrals over that to look at the dosage and so on. So it's all done very carefully, mathematically, in a very correct manner. And then finally, these are actually designed to be very nice, sliding units into existing ducts. So if you have an existing duct, you only need to cut a slot here and install certain rails that will be provided. And this whole thing slides into the duct like a drawer. So it is on the side of the duct. It doesn't obstruct the airflow like as shown here. The airflow is very smooth, and you can actually pull this whole thing out for maintenance, cleaning, because if dust coats these lamps, they become less effective. So this is how these things were made, and these have been installed in various places, like in the auditorium at NPL Delhi, inside the parliament, where we had to go for a very, very special large system because the ducts are enormous in size, and we have installed them into the Indian Railway coaches for air-conditioned coaches. And today RDSO has accepted, and the Railway Board has also recommended, and the Railway Board has accepted these to be now these units which are inside the ducts at the top of the ventilation ducts in the train. So these units have now been accepted as part of the design by the Railway Board, and future trains are all coming out with that. Presently, there's a tender from the railway to install these, which is ongoing. So all these were done on trains, and you have the control units and also the indicators, whether all lamps are functional and so on. We did them in buses with the UPSRTC buses. 2 buses are still running around with these UV devices in place. And, a mathematical model developed by CBRI shows that the risk of infection to a passenger by an infected passenger to the others in an 8-hour journey reduces from over 45% to about less than about percent. It's about less than 0.1% due to the UVC that disinfects the air that is actually circulated around the bus. We have other models where you don't have duct-based AC systems or centralized AC. You can have these standalone units which just recirculate the air, the second air from the room, push it through these disinfecting columns where there is ultraviolet light, and take them out. And these have become quite popular. We have had, many of our technology transfer partners have been selling these units quite a bit. So lifts are another issue. You see, so many people use lifts, and in the peak of the pandemic, in fact, this was noticed in the high-rise buildings of Mumbai, where people were affected much more in the high-rise buildings than in the smaller buildings. So rates of infection were very high there, and it was zeroed on that the lift was one of the culprits because people keep coming in, going out. So our solution was we developed these small units which pull out air at typically the level just below where a person breathes out. And this air is pulled in, sucked in into a device, disinfected and pushed out clean. And this is actually arranged along with the fan, etc., with the convection in the system so that the clean air is actually spreading out nicely at the level of the passengers. And then, you pull in the impure air to disinfect it again. So we have a variety of such things. These were put into toilets of trains. Voltas has taken these up for installation in the toilets in their new data project buildings and so on. So where the airflow in the toilet is designed along with this so that pure air is coming over the people using the toilets while, air is taken out at a level where it is the outflow from the expired air from the people are captured. So we have a lot of technology transfer. We did a lot of technology transfers in the first year. We gave it to practically almost anybody who asked for it. They just had to present their financial documents. It was epidemic at its peak. We wanted that maximum people have the opportunity to make it and maximum people could buy it. So that was a model that we adopted. And at the end of the day, several of these people have come back to us for a license for the second year. And, major companies are also coming up now, have come back and have come and taken the licenses. So I believe, so on the whole, this should be regarded as a very effective technology that was developed in a very short span of few months in order to respond to a national emergency. And it was validated as well within that period. And a validated solution was offered to the people qualified in certain cases in many of the aspects. And it was one of the only validated solutions available in the country as far as the COVID went. So I think I would essentially stop here and say that yes, the COVID pandemic was a huge challenge, but in CSIR, at least this particular project taught our 4 laboratories how to work together so closely and how to, just keep complement each other's requirements. And it was all done in such a brilliant, congenial, as well as, manner where all our scientists and staff and so on responded to the national requirements like anything. We had the COVID pandemic at its peak in May and June, and our technical officers from CSIO were scientists and technicians were in Noida, Noida bus stand or Ghaziabad bus stand, outfitting the bus with the AC system, the UV systems in their ducts. So they have been very fearless for their own safety and so on and so forth while taking precautions, of course. But they have done overall. CSIR scientists did a very fearless job and very good job at that one. And I take this opportunity actually to congratulate the CSIR scientists for rising to the national cause at a very critical juncture. Thank you. Thank you so much, Dr. Shukman.
Thank you, sir. Thank you very much for your wonderful presentation in which you have highlighted the technologies developed under the COVID pandemic, starting from air sampler to, UVC air disinfectant solution for HVAC in ducts, and then moving to the standalone air disinfectant solution. Then also the pure elevator and air disinfectant solution for the toilets, and some of the works for Indian Railways and buses. Yes, I think I would like to place on record a special thanks to Dr. Anjan Ray, who was the chairman of this particular group. Who led the team, and it showed that the entire CSR group is so capable of facing the challenges put in a short period of time. And I am grateful to all the scientists of CSIO Chandigarh, CSIR, CBRI, Roorkee, IMTech, Chandigarh, and CCMB, CSIR, CFTRI, NB, CMAP, Lucknow, and many others. And I'm grateful to each one of them. And it was great to work as a team, as you rightly mentioned, sir. And we look forward to have great such opportunities in the times to come, where we utilize our core, expertise and solve the challenges across the world, whatever challenges that we face in the near future. Thank you very much.
Yeah, thank you.
Yeah.
Thank you very much. I think I went back on my slides instead of going forward, and I wanted to just, highlight some of the heroes of this story that I presented here. There is not an inclusive, all-inclusive list, and I will ask the other heroes and heroines to kindly excuse me. Yeah.
No, there are heroes, sir. I am not a hero, but I was part of the team. But I am sure the team led by Dr. Anjan Ray, and then all the directors and the DG, former DG CSIR, Dr. Shekhar C. Mande, and many people across the CSIR labs who stood together and developed many technologies in a very short period of time. And I think in that period, almost around 2 years, we had weekly meetings, 70 weekly meetings, and wherein all compliments to Dr. Anjan Ray for spearheading the group, and and we all have contributed to the cause, to the challenge which was thrown to CSIR. Thank you very much, sir. I think before moving on to the next panel discussions, I would request anyone, two questions, one question to Dr. Shrikanta Panigari and another question to Professor Ananta Ramakrishna. Anyone who would like to ask a question from these two learner speakers? Please raise your hand. Anyone? I don't see any hand raised. So anyway, ladies and gentlemen, thank you very much, sir. I would like to again place on record special thanks to our both speakers who have, because of their busy schedule. Oh, I think there is one hand raised. Chandrasekhar.
Hi, sir. Thanks to all the dignitaries participated and given very incredible information, especially to Mr. Ananta Ramakrishna and Dr. Shrikant and Dr. Asur, the way you presented. Actually, this is the question with Dr. Ramanta Ramakrishnan. So I'm very, first of all, thanks to your team, entire team, really worked hard and developed something which is really credible and only agency who is validating. So in day-to-day life, actually, I have been interacting with a lot of MNCs and government organizations. The biggest challenge what we have been facing, that the way you presented and the way you tested everything and documented. So there has to have some tool or there are credible agency wherein we can validate our applications. We have been designing the system. We already installed more than 10,000 units, more than 500 projects executed. The biggest challenge what we have been facing, let's say doses you are talking about. The doses for the time being, ISRE has decided 1500. Earlier it was 4016 microwatt centimeter square. So it has been changing. But the customer, what they look for, how do you prove it? So we offered them pre and post tests. But some cases, like I'm giving you a reference in some airport, we have done that. I mean to say that the agency, we have to entirely depend on an agency. We are a manufacturer. We are manufacturing the system. We don't have that kind of a scientist portfolio wherein we can do the by our own team to validate and just to consolidate whatever the research and development your incredible team has done. So would you just help me weigh out how do we consolidate? How to win their confidence? This is really happening. Although our job is to just ensuring the doses, and we have a unique system, proprietary software also, wherein we can ensure and that the dynamic report it is coming through the sensor. What is the doses creating the intensity? But they are not at all thinking about that. This is recommended by the different agency. This is showing in your system, but how you will show that this is the area is virus free? If something happened, inside the premise,
Mr.
who will take the responsibility?
Mr.
Chandrasekhar, can I answer?
Yeah, sure.
Yeah. You see, insofar as virus disinfection or virucidal effects are concerned, with ultraviolet light, the only parameter that matters is the UV dose that you provide to it. Dose is intensity times the time for which you exposed it. This is the UV dose. Now, as long as these doses have now been measured by us in IMTech on live viruses and measured multiple times reproducibly. Now, once this is established, and this is also consistent with internationally what other laboratories have measured, it is not at variance with that. Now, once that is done, Once you put this intensity in your system, this and deliver the correct dose for the airflow that is present in your system, then one really cannot ask for more. If you want to, so what can be done? You can have an agency which measures the virucidal dosage for each variant of the virus or each virus, which we are also helping BIS with. IMTech is helping BIS with that. And eventually we are hoping that we are providing data to BIS. We are not helping BIS, we are providing data to BIS for their, their requirements. Now, similarly, some agency can measure the UV dosage. NPL Delhi can do it. It is the, for example, it keeps up all the standards, all measurements in the country. It is authorized and empowered to measure. So they can help you measure that. So agencies are there. Now these are the only two parameters you can measure. No customer can demand that, look, prove to me now in my room this is safe. Nobody can do that, because while the customer is speaking to you, some virus can come out of his mouth and then also you will not be able to say that that is virus free. So there are no such guarantees. Like, there are only reasonable assurances of disinfection, and that is something that these studies provide. So there is no guarantee that can be given to any individual customer by anybody, because this is only going to clean up the air that goes into the mechanical ventilation system. What air is there in the room, it takes a while for all of it to get circulated. So before it is circulated, if somebody picks up an infection, they pick up an infection. Nobody can prevent it. And no such claim is also made. All the claims that are made is that we are making it safer. And how much safer can be quantized. That's about it. It will not be 100%. Nothing is 100% in the world. I mean, I don't know. I might have a heart attack while I talk to you and pop off. There is nothing 100% safety here. So I think we must accept some of the vagaries of life, real life.
Thank you, sir. Thank you for taking this question. And I would like to add that, whatever Professor Nanta has mentioned, one of the technology called standalone air disinfectant solutions that he mentioned, there is a joint patent of CSIR, CBRI, and CSIR, CSIO. So again, compliments to that, and Chandrasekhar can very well see the patent and with more details. If he wants to have more clarification, he can write to Director CSIR, CSIO, or Director CBRI, or Director CSIR IMTech and others. Thank you. Ladies and gentlemen, now it's time to move further. We are now going to have the panel discussions, and under the panel discussions already we have listened to Dr. Anjare for his welcome address, but again I would request Dr. Anjare to say a few words or a few points on impact of climate change in built environment in the cities, towns, or maybe in villages or urban villages, and in buildings as well. Over to you, sir.
Thanks, Dr. Ashok. So let me build on what our two very distinguished speakers have said. Apart from the heat island effect that was discussed, and apart from the increasing issues around air quality in our cities, climate change is an all-pervasive phenomenon. So apart from the biodiversity loss that was mentioned by Dr. Panigrahi, apart from the pure air quality issues that were mentioned by Professor Ananta Ramakrishna, apart from the indoor air quality issues that one has sought to address with the virus management systems, I think the entire aspect of climate change for today's panel discussion, particularly because of the background of our distinguished panelists here, should focus on, first of all, largely we know what is causing this. But what we'd like to learn from the discussion is, how does one address this in a time-bound, measurable manner. How do we know that what is being done, the actions being proposed, how will we know those actions are actually going to mitigate climate change, both in terms of the potential impact and in terms of the absolute quantum of greenhouse gases in the air? Also, there are secondary effects of climate change. So, for example, as the outside temperature goes up, the use of air conditioning becomes a challenge because air conditioning, like any other machine, is going to create an inefficiency and is actually going to create more greenhouse gas on a net basis, especially because in an air conditioning system, we cool not only the person we want to cool, but we also cool the furniture, the walls, and everything else in the room. So is there a need to relook at our urban solutions to climate comfortable buildings? Is there a need to relook at urban solutions to structures, not only from the point of view of the occupant, but from point of view of the planet? With these initial thoughts, let me hand over to a very distinguished panel.
Thank you, sir, for setting the context for the discussions. Now, I would invite Ms. Anuvita Roy Chaudhary, who is the Executive Director, Research and Advocacy Center for Science and Environment, New Delhi. Over to you, Ms. Anuvita Roy Chaudhary.
Thank you so much, Dr. Kumar, and it was great listening to Dr. Ray and Dr. Ravas Krishnan, and yes, Dr. Panigrahi. It's fascinating to meet all of you here. So I'll briefly touch upon the implications of climate change and the linkage with the built environment and what we have been able to understand so far and how that reflects on where do we need to go. So if we really try and understand, first of all, that all of us here are talking about climate change, its impacts on built environment infrastructure, but let's first keep in mind before we go further ahead that what India's commitment in COP26. And if we look at that, India is now has made a pledge to reduce 1 billion tons of carbon by 2030, and at the same time, reduce energy intensity of the economy by 45%. Now, to be able to do that by 2030 has huge implications for built environment, which is one of the biggest energy guzzler, if you really try and understand that in terms of sectors. And taming carbon emissions and energy intensity of the built environment is not going to be easy, keeping in mind that climate stress, the heat stress, like what Dr. Ray just mentioned, that how that stress is going to lock in more carbon in the built environment in the buildings because of our increased dependence on mechanical cooling. And in fact, the analysis that we have done of electricity consumption in Delhi, for instance, during summer months, it's fascinating to see that how demand for electricity during the day and night, and it peaks normally around afternoon of summer, but we have found peaks even during midnight. And sometimes the night peak can be higher than the afternoon peak. And that is all the effect of mechanical cooling. And this is what is going to increase more and more. And we have just gone through one of the worst heat waves episodes of the century. Another reason is that we are also going to build very, very rapidly. I mean, India's residential sector is adding at least, about 180 million square meter of residential floor area every year. And with that, if we don't pay attention to reducing the energy intensity of the built structure, and if then this can lock in enormous energy and efficiency during the operational phase of the buildings. And this can compromise India's cooling action plan target, which is saying that of reducing the target that says that we need to reduce cooling demand by at least 25 to 30% and cooling energy requirement by 20 to 40% by 2037-38 in that time horizon. Another big reminder, it's a lasting reminder that we got from the COVID-19 pandemic, when it has challenged us to look again at the way we are designing our buildings, choosing our material. And it is so clear from that episode when it's saying that and you will remember because CBRI has played an instrumental role in developing the guidelines for air, how to use or not to use air conditioner, but more important, on ventilation in buildings. And that during that context of pandemic. And which is clearly saying that if we do not design buildings for livability with good ventilation and for thermal comfort, and if we continue to increase dependence on mechanical cooling, then the buildings are just going to turn into petri dish and increase disease burden. So looking at all of that, at the Center for Science and Environment, we have therefore tried to assess how the mass housing is actually evolving in this country, how that is getting designed, what material choices are we making. And when we did some of these case studies in Telangana, for instance, and what we found that even if you try and apply some of the passive architecture indicators that you have, eco-sanhita that has been designed for residential sector, and if you look at the daylighting requirement, ventilation requirement, all of them fall short of what even the eco-sanhita is asking for. And I'm saying this when at this moment we have not yet developed benchmark and guidelines for thermal comfort standard, which India Cooling Action Plan has asked for. So when we saw that, it is very clear from our perspective that only for focusing narrowly on energy efficient technology and energy and material in buildings is not good enough. We really have to look at what India Cooling Action Plan is asking for, that just don't design for efficiency, but design for thermal comfort for all. And this means that not just the affluents, but also the low-income groups and the affordable housing that we are preparing today, you have to design them and make them to be thermally comfortable. But the challenge is that when we are looking at the real estate sector today, the whole influx of the new material and the new walling material that is coming in today, all the prefabricated materials that are being taken up, and this is happening under Pradhan Mantri Awas Yojana, and we are looking at those materials today. Now, this influx of new material and technologies are largely prefabricated, manufactured, and these are preferred by the industry because even if they are more expensive than the conventional material, but they are still preferred because they save on time, they save on labor, and it reduces their loan repayment burden. And we have found that the precast can save up to 50% of the time of construction, and that's the incentive for the builders. But if the thermal properties of new material are not assessed before adopting mass housing, adoption in the mass housing sector, I mean, houses can become the heat trappers. And some of these new generation materials may be good for fast construction, but they may be thermally uncomfortable because, in fact, we have seen some of the studies show that if you take a monolithic wall panel and made of poured concrete with thickness of just, say, 100 mm, that thermal transmittance value of that wall can be much higher than the conventional brick wall. In fact, it can be as high as 60% higher. So this clearly asks for, it demands new benchmark, toolkits, guidance, and mandate to influence walling assembly, selection of material, insulation, and more important, adoption of passive architectural design to reduce the overall thermal load on the buildings. And unfortunately, today, the fiscal support that is being given for the affordable housing sector, which is huge in terms of incentive, but these are not linked with thermal comfort requirements. And therefore, we now need to look at that how fiscal incentive design can be designed, because additional costs of thermal comfort design can be higher. And therefore, we have to offset that cost. And we have to look at performance criteria when we are giving fiscal support, and that will to improve the overall operational efficiency and increase thermally comfortable hours and reduce air-conditioned hours in the building. So to sum it up, what I would really like to say, that if we do not address all of these, then we are going to be in big trouble. But the good sign is, and that is the reason for optimism, that currently Ministry of Housing and Urban Affairs, and this is also part of the mandate of the India Cooling Action Plan, which is currently working on the Thermal Comfort Action Plan 2050. And they're also developing thermal comfort standards, guidelines for the buildings. Now, this is a huge opportunity because this is expected to guide the building designers, architects with set of requirements to ensure that the building is as thermally comfortable as it can be within a specific context of the climate, ecosystem, and activity of people, and reduce the impact of outdoor conditions on interior without, as much as possible without air conditioning. But this is certainly cannot be prescriptive, because thermal comfort is an idea. It has to be kind of, done with a lot of permutation combination. But it is important to give that guidance to build so that we can have healthy, productive environment. But this is not an exact science, as I said, but we have to understand the sensitivity and the correlation of building parameters. We have to look at the performance of the minimum enhanced, the performance characteristics. So all of that will be needed. But this is a great exercise, and as a scientific community and everyone together would need to contribute to that exercise. And what we need to keep in mind to kind of bring this to an end, that the opportunity of framing thermal comfort standard is really big in India today, keeping in mind that nearly 80% of buildings in India are naturally ventilated or are a mixed mode. And so we are not fully, completely dependent on the air-conditioned or mechanically controlled environment. And that's the opportunity for us. So if we can work on this, we can certainly reduce and prevent the lock-in of carbon and energy in the built environment. And this can also enable performance-linked funding. Otherwise, what we have all been saying, that the rising heat and the climate impacts is going to increase air conditioning, use of electricity, energy, also increase out-of-the-pocket expenses of the households, energy bill of the country, and it will just kind of increase the climate change cost of the built environment. So this is what we really need to keep in mind if we have to help India to meet its target of reducing 1 billion ton of carbon and 45% in reduction in the carbon intensity of the economy by 2030. Thank you very much.
Thank you, Anvita, for your wonderful words of wisdom and highlighting the importance of thermal comfort standards and also the materials, the technologies that are likely to be used in buildings and that are yet to be built, and also the challenges that we have before us on PMAY urban, where a lot of new technologies are being utilized. And I just wanted to inform you that we at CBRI are very much concerned about all these issues that you have highlighted, and we have already done a significant amount of work. If I talk about early 80s, the handbook on functional requirements for buildings is one of the Bible document that every architect and engineer reads. That also supplements the guidelines and the knowledge that has been developed at CBRI and has been included as part of National Building Code on several previous like NVC 2005 and now 2016. And you mentioned about thermal comfort standard. Yes, we are part of that committee, including yourself. We all sit together and we discuss about that. And we also have, tried to demonstrate some of the technologies at our construction demolition and demonstration park at CBRI, wherein few technologies are being, monitored from not only structural performance point of view, but also from overall performance, including the thermal comfort. So maybe in next about 4 to 5 months, we'll get some data. But theoretical validation of these is also done so that theoretically we are sure that how these technologies, when we use them in buildings, they perform in different climatic zones of the country. So that all work is going on, and thank you for highlighting the importance of quantifying the parameters, which is essentially very, very important when we say the integrated effort of reduction in the overall thermal loads and energy bills, and that will also lead to reduction in the net zero. So thank you very much, Anvita.
Thank you.
Now we move on to the next speaker. Ladies and gentlemen, we have Dr. Santanu Goswami from Azim Premji University. Over to you, Shantanu.
Thank you very much, sir. Yes, I really want to thank you and Dr. Kumar for giving me this opportunity, and say it's a great pleasure and honor actually to listen to eminent speakers, including Dr. Panigrahi. So it's very thought-provoking what we have been discussing about today. But as a my probably take on things would be more as a climate scientist. Because this is what I've been working on. So we know about the scenarios that we talk about that we are going to see into the into the future climate change scenarios. I want to actually focus on two things, maybe with a bit more detail. One is how the temperature is going to change and how the precipitation is going to change. And rather saying, instead of how the temperature is going to change, I should say how the temperature extremes are going to change and what are the implications. And what are the precipitation extremes are going to change, what are these implications. So when you think about precipitation extremes, then I'm talking about the flooding scenarios. So so we are actually creating future scenarios for India for different emission scenarios right now using bias corrected data with information at the district level. And what worries are, as we are looking at the scenarios rather closely with a lot of attention to detail. So what worries us that a lot of these areas they are going to see some extreme changes. For example, we talk about that sea level rise and how I mean, basically we know that sea level is already rising, and we talk about how these this change is going to affect the flooding scenarios, right? And then you think about like extreme rainfall event. So basically, how much rainfall you are going to get in a short span of say 1 day or in a short span of 5 days, which can lead to flash flood into these into this urban environment, and how that can create havoc in this in this landscape. So then when you talk about actually when you talk about that temperature extreme, that's probably a lot more worrying than precipitation extremes, basically like flooding, because when you talk about the temperature increase, we it's, I mean, some areas, especially on the northern side, some areas are going to get extremely hot, right? And then along with it, what we are seeing that humidity is going to rise as well. Now, if we combine humidity and temperature, then we talk about something called wet bulb temperature, that is a thermal comfort. But it sounds quite nice, thermal comfort, but it's a pretty dangerous thing, because if we are going to talk about the the wet bulb temperature, it's when it hits about 31, 32, people can't really survive, even if people are like staying in a shaded place and they are having enough water. And in the recent IPCC report that just came out, one of the reports actually says that India is going to see, in the the normal like basically business as usual scenario, India is going to see 31-degree heat bulb wet bulb temperature in the next 100 years. And a lot higher for high emission scenarios. So now, if we think about it, why this is so crucial, or why this is so worrying? Because when it comes to the Indian working population, about 45% of the population work outdoor, right? We are not really talking about people who are under the AC. And so if we are going to see all these extreme scenarios, for example, this year India has already seen 280 heat waves, which is, to my understanding, it's the highest in this decade, right? So if we are basically in the last decade, so if we are going to see more of these scenarios, right? So yes, we are going to be consuming a lot of energy, which is going to harm the atmosphere a lot more. But what about the urban poor? We have a lot of people who do not have access to these rather say luxury, and then how do we actually like going to think about how we're going to save them? The other question is, when we develop this climate action plan for the cities, are we developing inclusive plans? My question is, when I say inclusive plans, I'm saying, are we really thinking about all those migrant laborers who actually like migrate to the cities, and they live in not so good conditions, right? And if we are going to think about the loss of biodiversity with the change in the climate, that means a lot of, and like say drought scenarios and basically other climate scenarios, a lot of the communities who are living in the rural areas, they are going to become poorer probably. That means they will be forced to move into urban areas where they will find some job. Then that the whole problem becomes really, really critical. Then again, I mean, the climate change is very unequal. Climate change is very, very unreasonable. So then when you're thinking about India, the way it's developing now, how do we have a balance with development and the nature? I think that we might have a solution right there. As Dr. Panigrahi said, urban areas are parasites when it comes to the environment. That is completely true. But can we actually think about having these areas, rather the parasites for the environment, into something more sustainable? So what about bringing in the ecology back to the, back to the urban areas, right? As there will be more building, hopefully building with less energy consumption, hopefully buildings with a lot more environmental friendly material. How about integrating the ecology to those buildings? Maybe like think about doing vertical gardening. And how about and we plan on replenishing the trees that we are losing now because of the development as quickly as we can, right? How about increasing green spaces, and how about we go after actually reclaiming those wetlands that are increasingly being lost, right? So these are rather the problems actually I'm posing out there. But when I'm posing those things, I see a lot of opportunities in here. Opportunities in terms of actually innovation. So if we are going to think about climate action, and we're going to think about climate resilience and basically how do we adapt to this, to this climate, right? I think there are lots of opportunities in terms of technological innovations and also in terms of social innovation. Rather, maybe I can even say the social entrepreneurship. So this is where I think the researchers, the university, the research labs, the companies can come in together to think about or brainstorm innovation that can really help. Because we know only technological innovation is not going to solve it. It's a rather complex problem. If we are going to go for only technological solution, maybe we will be developing solutions for just how do I say, like just one section of the society, right? And then another thing, actually, I personally feel, and that's why I have been working with a lot of young people recently. How do we encourage a large section of the young people to join hand and train them up as a next generation of how do I say? Maybe I rather say climate activists. Climate activists can be climate researcher, climate scientist, climate like communicator. And how do we actually think about building a generation of that group to help us solve or help solve this climate climate problem for our cities? And that actually applies to actually other other areas as well. And then when I think about, again, maybe I should say one more thing as I'm thinking about it. When you say cities or urban areas, maybe we suddenly think about these big cities that we actually see. Of course, big cities are where major problems are, because it's very, very complex, and it's a lot of people out there. Then we should also think about the cities that are actually up in Himalayas. This is probably a less discussed point, but Himalayas are very, very vulnerable to climate extremes. That is also because of the changes that we are seeing as a forecast. For example, Ladakh is going to have very heavy rainfall. And Himalayas is sitting on top of a landscape called permafrost, which is very, very less studied in India, even though it is widely studied all over the world. And that degradation to that landscape with extremes, change in extremes can lead to very catastrophic situations in these Himalayan cities as well. So, I mean, having said that, I guess I should summarize that, we should think about planning uh, to have an inclusive environment where you can think about actually tackling some of these climate challenges. So, thank you very much, sir.
Yeah, thank you, Dr. Santanu, for highlighting some of the very important issues of integrating ecosystems in the built environment, particularly mentioned about vertical gardening and things like that, and with increased open spaces. And yes, there lies the importance of an integrated approach, which I mentioned in my first slide that I introduced in the August gathering, that these are the context for discussions, and I'm sure the audience who is listening to all the speakers, they must have been enriched by the kind of deliberations that we had in these in this session and the previous session. But as a whole, I can I can say that when we are talking about these at the micro level buildings, or built environment, we also need to concentrate on a macro level at the large towns. We started as a young architect or scientist, we started working, when we know cluster of buildings will form a community, and a number of communities will form a neighborhood, and a number of neighborhoods will form a small towns and larger town like that. So like I think those older concepts that we used to deliberate upon during early 90s, they are I think even today they are worth researching upon by our young talent, and there, yes, we need to be ready with alternatives, and we need to be ready with standardized plans and layouts, standardized materials and technologies, standardized modular building components, standardized light services, and much more. So I think we have to have an integrated approach, and we at CBRI are very well placed, wherein under one roof we have all the disciplines, and we look forward to have more future collaborations with Dr. Srikanta Panigrahi and Dr. Shantanu, and Center of
Looking forward to it.
Environment, Mrs. Anvita Roy Chaudhary, and this is all I have to say. Now the house is open for question answer. Please raise your hands to the concerned speaker so that they can respond to your query. Please raise your hands. Yeah, again, there is a V. Chakradhar from CSIR CBRI. Yes, Dr. Chakradhar.
Sir, very good.
Yes.
Hello.
Yes.
Sir, am I audible?
Yes, yes.
Sir, very good afternoon to everyone. Here, after going through this discussion, I would like to point out one thing, sir. Here, whatever the energy demands or the cooling which we are planning, the ACs are consuming huge amount of energy. So even the madam was rightly saying, like in Delhi, the peak electricity demand is happening sometimes in midnights where the ACs are on. So to come up with the solution, I feel like we have to segregate the complete cooling loads and the rest of the building loads separately, sir. Like for a normal residential home, whatever the Indus furnaces, whatever the other washing machine, whatever the other gadgets are available in the house, the load should be completely separated from the cooling systems. Then we can evaluate what exactly the the load of the cooling systems are. And I would like to ask, like, there are ECBC plan like ECBC plus super ECBC. Such documents, they describe about the energy utilization, but they don't. But the document doesn't ask for or from where the energy source is. Like it is a renewable source of energy or it's a non-renewable source of energy. I mean, as of now, we don't have any code which categorizes the building based on the type of energy it is utilizing, sir. So I think we must work on some document like based on the energy type in which the building is utilizing. We should rate the building and we should quantify that data.
So what is your question?
Sir, the question is how the sir was saying. Sir, I would just like to tell like we should work on this, but we should quantify the type of energy which is going into the building, sir.
So this question is to whom? To
Uh,
Spandu?
Sir, to everyone, sir, because you are even saying like earlier you had made the guidelines, but now there is a time like which we have to work together and we have to make a comprehensive guideline which rates the building based on type of energy. Apart from net zero, if we can make net zero by solar PV and whatever the other ways by using high efficient gadgets inside, apart from that, what type of energy we are going using inside the building, like we may have a small what is it 1 moment, I'm not getting it. Organic Rankine cycle which can be run in the inside the building and it can become an energy source, which is means like using solar we can run an organic Rankine cycle and we have to rate the building and we have to give I mean we have to make some documents, sir, which rates the building apart from
So thank you for your points. Just to answer some of your questions or some of your issues that you have raised.
Yes, sir.
As I mentioned in the opening remarks, that we at CBRI did a significant work wherein we tried to quantify the parameters for improving the thermal load or reducing the thermal load. And also that will definitely reduce the energy consumption. Both theoretical as well as experimentally, we have, one is the baseline model, other one is the retrofit model, improved model. So that means we are already having, established the science that with the use of several parameters, these are called, passive design features, and following the building physics principle, we can reduce the thermal load to the tune of about somewhere around 50%.
Yes, sir.
Number one. Number two, the rest of your 50% can be addressed by adopting any alternative solutions,
like passive cooling,
renewable solutions, right? So there are a number of studies and many Dr. I think Nagesh is here. I see Dr. Kavish also. The effort on this solar thermal air conditioner, that developed by our scientists, and many such efforts are going on. And yes, there is a lot of research which is required. And yes, I agree that, for rest of the 50% that we want to use, we need to have a quantified data. Yes.
Yes, sir.
Okay.
Okay, sir, and one more question, sir. Like as Madam was saying now, all the building manufacturers, they are using prefabricated building structures and to reduce the time of manufacturing the houses and all. So one more thing is, sir, like the as Madam was rightly pointing out, like the thermal properties of these materials had not been evaluated, and there isn't any documents which says like with these thermal properties, like India is classified into different climatic zones. I'm not finding any enough document which is authorized by the government to control the parameters. Like in this climatic zone, the thermal properties of building material should be so and so. There isn't any control documents. It is generic and it is declarative, and it is purely to the choice of the builder who he can design. So I think we should make one control document for different climatic zones of India so that the cooling load can be reduced, sir.
I think you can read one of the best documents of CBRI That is
Yes,
the
sir.
functional requirements of
Yes,
building.
yes, yes, sir. I mean, the
Let me
document is
complete.
available, sir, but
Let
it
me
yes,
complete. Number one.
yes, yes,
Number
sir.
two, we have recently done a research study
Yes,
under
sir.
this CSR project, SCP 0015, that
Yes,
is CSR Mission Mode project on mass housing,
yes, sir.
wherein we have developed standardization of designs and layouts for housing
Yes, sir.
units with improved thermal performance,
Yes,
wherein we talked about 30 to 40 different plans for the EWS and LIG houses as well as MIG houses,
yes, sir.
and discussed how these how these buildings can be designed
Yes,
in different climatic zones of the country
yes,
by using different materials and technologies that are available in the country and
yes,
across the globe with improved thermal performance.
yes,
So
yes.
you please read that document and come
Yeah.
out with some constructive suggestions on
Yeah.
this. I will be
No, sir. I
happy
mean,
to.
document is available, sir, but control is not less. Like again, still it is to the choice of the person who is building the home. I mean, it is not ratified by the government. Like it must be the, for example, the overall heat transfer quotient must be it should lie in this zone. Means we have developed the document, but ratification from the government is one of the parameters, sir.
Okay, okay,
So,
that is for
sir, can
because yes.
I comment something, because I think it's a very important question, even though he's asking that question for building materials.
Yes.
As I said, climate change is very, very unequal, right? And so one solution doesn't fit all.
Yes.
So I think that is something that we must recognize when we are developing these action plans, climate action plans for all the different cities and different parts of the country. I mean, we as a climate scientist, I know how different scenarios are, and I mean, I don't know how the like anomalies are going to be, and then we know how different even the landscapes are. We know how different the climates are. We know how different, like all these topography and everything is. Now, if we actually adopt, I'm not saying we are adopting it. I haven't really I'm not saying that we are adopting like a generic approach, but when it comes to developing climate action plan for different cities, right? We must develop this individually for each cities or each category of cities. Otherwise, this is, I think impact that we're going to see from this climate change it's really merciless. And we are talking about India, and we are talking about a lot of people who do not have access to a lot of resources, and we must develop these action like plans, suited for these category of cities or for particular cities, so that we reduce the impact of climate change on people. I think it's, even though you ask a question for a different thing, I think it is something that I think we should highlight it. So it is very
Yes,
important.
yes, sir.
Yeah, thank you, Shantanu. But
I would like to add to all the viewpoints. You asked that building net zero. So for to become a building net zero, it's important to understand the source of the energy it is drawing. Largely, it is grid-based energy from the grid. The domestic lines are there, and they draw the electricity for its consumption. But uh, these days, rooftop solar programs are largely getting implemented throughout the country. And Bangalore is having highest number of rooftop solars. In Delhi and NCR, it is increasing. Rate is increasing. In a rooftop solar in a particular building, when at the roof you have installed solar, if the energy installation capacity may be something, the production of energy could be little less than the capacity. Depends on so many factors. Then the consumption of the building. If the consumption is less, the excess amount of energy goes back to grid.
Yes,
And again, So the kind of actual consumption of energy from the grid and kind of the energy being generated by your own building system, that is going to grid. The difference between that on that basis your monthly electricity bill is worked out.
Yes,
So,
sir, on net metering.
sometimes whatever the solar installed electricity, if it is building is totally consumed the electricity need from its solar installation, then it is 100% renewable source. But if it is drawing from the grid 80% building installed solar and rest 20% from
20% from grid.
additionally drawing, then you need to see the energy mix of the grid. Like in Delhi, we had one NTPC thermal power plant which is supplying to grid in Delhi and NCR. We are also getting huge hydro energy from Uttarakhand as well as Himachal. So thermal is mm, uh, having higher carbon footprint, and so accordingly to make a building net zero, all those sources calculation needs to be taken. That is one. Next, you told segregating air conditioning from the other kind of load.
Yes.
Then such kind of design has to be done right from the beginning. But largely in present system, we don't have those kind of design arrangements. So that is my opinion.
Another point which I would like to highlight here is that, when Ms. Anumita was highlighting the importance of drafting, thermal comfort standards, there is a project of GIZ Germany, and they have sponsored this project to one of the agencies, and we are one of the stakeholders contributing towards that. And I know wherein the point which was, raised in the discussions that, what kind of climate is expected, say, by 2047. Are there any forecasting models that are to be desired, to be followed when we design buildings today that will have those climate change scenarios to be built in? So that is another kind of a system or a challenge that is there. CBRI did some good study under Indo-US project on revising the climate classification based on studies that out of these 5 climatic zones, now we have proposed 11 climatic zones, and Kishore Kulkarni and from IIT Roorkee, Professor Rajshekhar have done very good work, and IIT Roorkee is also developing forecasting models for 2080. What are the climate change scenario under the Indo-UK projects, where I am also associated with developing strategies or the guidelines for zero peak energy design for India. So all that work is going on, and this is very well is in line with the climate change scenarios, and yes, the knowledge towards net zero. Any other question? Any other?
Thank you. Thank you.
But Chakradhar, you please join hand with Mr. Anup K. Prasad for developing an OLP on such problems that are being discussed.
Sure,
Right?
sure, sir. Sure, sir.
Okay. So any other question? I saw some message in the chat box. Let me check the chat box. I am interested for technology from Reliant Systems. Please, because now the whole house is open for all, so please raise your hand. Is this question to everyone or to Professor Ananta Ramakrishna? What is this technology from Reliance System? I don't understand. Who is this person? Please introduce yourself. 2649 2641290153. Yeah. What is the question? I am interested for technology from Reliance Systems. I don't understand the question. Is this the, yeah.
I think, sir, he may be interested in the technology that UVC-based air purification systems. In that, he may be interested.
Yeah, that's what I was interested to ask from him. If he is on, he is live, then he can share his thoughts. He can, ask questions from Professor Ananta Ramakrishna or anyone from CBRI team. Yes, Mr. Or Mrs. Miss 2641290153. Because there's no names, or I cannot ask the individual. There is only this message from this particular, I think, anyway, so I think there are no more questions. Kishore, over to you. We are already at the end of the session, and it's 4 o'clock, 16:00 hours. So we started around 3 months later after 2. So over to you for proposing a vote of thanks.
Thank you, sir. So we are at the end of this particular event. So once again, good afternoon to everyone, to one and all who is present here. Plenary speakers, Dr. Srikanta K. Panigri, Director General, Indian Institute of Sustainable Development, New Delhi. Respected Director, Dr. S. Anant Ramakrishna, CSIO Chandigarh. Panelist, Director, Dr. Anjan Ray, CSRI CBRI Roorkee. Ms. Anumita Roy Chaudhary, Executive Director, Research and Advocacy, CSE New Delhi. Dr. Shantanu Goswami, Senior Scientist, Research Center, Ajiz Premji University, Bangalore. And industry partners and all the participants. It is such an honor for me to get this opportunity to thank you all dignitaries on behalf of CSRI CBRI Roorkee. I like to express my gratitude to all the esteemed delegates of the iConnect 55 for their presence and contribution to make this event a grand success. First, I would like to thank Ministry of Science and Technology, Ministry of Earth and Science, Government of India for giving this opportunity to organize this industry connect event on climate change and its impact on urban ecosystem, ICEN 55 at CSRI CBRI. I also thank our beloved director, Dr. Anjan Ray sir, CSRI CBRI Roorkee, for providing encouragement, support and guidance in organizing this event. I extend my gratitude to our plenary speaker, Dr. Srikanta K. Panigri, to take out time from his busy schedule to grace this event. Thank you, sir, for inspiring and encouraging us with your words on this special day. I thank our another speaker, Dr. S. Ananta Ramakrishna, sir, Director CSIO Chandigarh, for his presence. We are really enlightened with your knowledge, sir. I may like to express our sincere thanks to Ms. Anumita Roy Chaudhary and Dr. Shantanu Goswami, panelists, for gracing your important work and sharing with us your findings and opinions today. I thank Dr. Ashok Kumar sir, outstanding scientist, CSRI CBRI, for moderating this particular event. I must thank the organizing team from the CSRI headquarters, Dr. Vibha Malhotra, Devendra Singh, Rakesh Pal, Hemant Kulkarni, SK Tiwari, Mahendra Dhurokar, and from CSRI CBRI, Dr. Ashok Kumar sir, Nagesh Palam, volunteer Janvi Chava, Krutika from CBRI, and from CSIO, Dr. Harigar Ritika Singh, for working day and night hard for this event to make success. I am also thankful to Ms. Palak Dikshit and Ritik Sen Gupta from ATECON for providing technical services for this particular event. At the last but not the least, I convey my sincere thanks to all the participants for their active participation. Thank you everyone once again for making this event as a grand success. Thank you, sir.
Thank you very much.
Thank you. We'll meet you,
Thank you.
meet everyone
Sure.
soon. We'll invite
Thank
you
you all.
physically.
Thank you. Thank you.
Thank you,
Namaskar.
sir. Thank you. Namaskar. Looking forward to it. Yeah, thank you very much. It was an honor to participate in this.
Yeah, we look forward to invite Dr. Panigarai and Shantanu for special occasions.
Looking forward to it. Yeah, thank you. Nice meeting you, sir. Dr. Panigarai, sir. Yeah. Bye-bye.
Thank you, Kishore, for your hard work.
Thank you, sir.